Okay, so we'll start now. So yesterday we were discussing the basics law in electric circuits. Okay, so we already seen Kirchhoff current law. Now I'm going to discuss Kirchhoff's voltage law. Okay, so that give me 1 minute. So Kirchhoff's voltage law. So Kirchhoff voltage law says that algebraic sum of voltages around any closed loop is 0. Okay, so if I go through a closed loop or circuit, okay, so what can be there? So there can be a battery like this, a voltage source. Okay, if I go from here to here, so that will be what will be this is the high, this is the potential, higher potential, and this is a lower potential. This is called voltage drop. This is called your voltage drop. Okay, and if I go through a battery from negative terminal to positive terminal of battery, okay, and I'm moving in the loop like this. This is your voltage rise. Okay, similarly in the resistance, if I am moving in the direction of current, so current always moves from higher potential to lower potential. Okay, so this will be your V will be your voltage drop. So here V, whatever V is there, that is your voltage drop. V equals to IR, that is your voltage drop. Okay, so this is your here voltage drop. Similarly, if you go resistance from minus to plus, okay, minus to plus in the opposite direction of the current. Okay, so this is your voltage drop, and if you're moving like this, okay, that is voltage rise. So now Kirchhoff law says algebraic sum of voltages around any closed loop is 0. Okay, so in the circuit you will counter either voltage drop or voltage rise. Okay, now it is your choice whether you want to take voltage rise as a positive or voltage drop as a positive. Okay, or vice versa. Okay, so generally what I do, I take voltage drop as a positive, so it makes me my job easy. So whatever sign I encounter, I can write that sign. Okay, so what exactly I'm trying to say? Okay, let me give you example. For example, if I have a circuit, okay, so this is say V1, this is V2, okay, this is V3, and I have a battery like this, say this is V4, and okay, and I have one more element here, okay, where I have this V5. Okay, so if I go from here to here, this is the voltage rise, this is voltage drop, voltage drop, voltage rise, and again voltage drop. Okay, so now if I write the so first of all I have to define a current in the circuit, which this single loop circuit. So I have to define the current, which direction I'm moving. Suppose I'm moving in this direction, okay, clockwise. So I will write this is minus coming here, so I will write minus. If you want, you can take positives. You can take voltage rise as a positive, okay, but I'm taking voltage rise as a negative. So whatever sign I encounter, I will write. So for me V1 will be negative, okay, V2 will be positive, then again V3 will be positive for me. Now V4 is coming, so I will write minus V4, and then V4 is coming here, I will write V5, and this is the algebraic sum of voltages, okay, voltage drops and voltage rises, okay, is 0. Okay, now if I write this one, so I can write my V1 plus V4 equals to V2 plus V3 plus V5. Okay, so this is V4 voltage rise. This is this is a your voltage rise. This is also voltage rise. Okay, so sum of voltage rises. Okay, sum of voltage rise. Sum of voltage rise is equal to sum of voltage drops. Sum of voltage drop. Okay.
Sir,
Huh.
here we take voltage raise is for negative, no?
Which one?
Voltage raise.
Voltage rise. Voltage rise. I'm taking negative. Okay.
Okay.
You can do opposite also, so that will not change. Okay. So basically, sum of voltages. Okay. Sum of voltages around any closed loop is zero. If I write this is as a VI. Okay. I barabar 1 to n. Okay. So sum of voltages around any closed loop is zero. That is your Kirchhoff voltage law. That is basically due to conservation of energy. Okay, this is basically energy conservation law. Okay, because V is the potential. I can write V as a W by Q. Okay, so this is sum of work done. Total work done in the circuits will be zero. Okay, or you can say this is the conservation of energy. Now we'll understand this Kirchhoff voltage law through a problem. So
Sir,
tell me
a voltage raise we shall take positive also, no, sir?
which voltage?
Voltage raise, sir.
Voltage rise, I am taking negative.
We take positive also, no, sir?
You can take positive also. If you take positive, then you take voltage drop as a negative.
Negative.
Okay. But
Okay.
here I am taking minus as a positive through minus because whatever sign will come, I'll write that sign. Okay. So voltage rise is negative for me, voltage drop is positive for me. You
Positive.
can take
Okay.
voltage rise positive, voltage drop, you can take negative. Okay. That will nothing will change. Okay. That is your choice. Now let us understand this with a problem. So you have been given, say, circuit. Okay. Say this is my plus 20 volt, 20 volts. Okay. Say this is 4 kilo. Say this is 6 kilo. Okay. And then say this is I have minus plus 10 volt. Okay. Minus plus this is a 10 volt. Okay. So I want to find the current in the circuit. Okay, so let us define I. I is the current in the circuit. Okay, so how can I solve the circuit? I want this single loop circuit, single loop. So I'll apply voltage KVL. So I'll start from here. So I'll add minus 10. Okay, so make it this also minus plus. Okay, minus plus. Okay, then minus 20. Okay, here current is moving here. So what is the voltage drop? What is the voltage drop here? What is the voltage drop here? I into R? Yes or no? Okay. So current flowing here is I. So I into 4 kilo ohm. So that is 10 to the power 3. Similarly, this is 6 kilo ohm. Okay. Current is same I. And this is your 6 kilo ohm. 6 into 10 to the power 3. Okay. Let it put it to 0. Now this 20 minus 30 become 30. And this you have become I4 and this is 10. Okay. So I and you this has become 4 plus 6 10 10 is to power 4 equals to 30 volts. Yes or no? Okay, and now if I want I, so I can write 30 upon this, I can write 10 into 10 to the power 3. So 3 and this will go up to 3 into 10 to the power minus 3 ampere. That is current is I is my 3 milliampere. Okay, so once I know the current, I can find what is this voltage here, voltage drop. Say this is VV. So if I want voltage here, say this is V1 and say this is V2. So I can write my V1 is 4 kilo ohm, current is 3 milliampere. So 4 into 10 to the power 3 into 3 milliampere. Okay, total become how much? 1412 volts. Similarly, if I write V2, so V2 will be how much? 6. Okay, 6 kilo ohm into 3 milliampere. So this become 18 volts. Okay, so this is a voltage rises. So voltage rise is 30 volts. Voltage drop is also 30 volts. 12 plus 18, 30 volts. Okay, so in this way you can check. Okay, so whenever batteries are in series, you can add them also. Okay, so finally, if you're seeing this minus 10 plus 20, they are in series. So finally, I'm adding them. So if you want, you can remove this 2 batteries and you can put 1 battery in the circuit to see the simplify the circuit. Okay, now if the sign is opposite, you can take you can subtract them. You can take algebraic sum of these batteries. Okay, whenever they have same sign, or you can put minus also when they are in opposite sign. So you can replace one source by many sources by a single source. Are you getting this point in the circuit? Okay, so this is one simple question. Any question? Anjana, Abhi, Nidhi, is there any
No,
doubt?
sir.
Okay, so let me give you one more simple example. So in a given circuit, find V1 and V2. Okay, we'll start with simple problems first, so that we should know how to apply these laws. Okay, so suppose 20-volt battery is given, and you have been given here 2 ohm resistance, 3 ohm resistance. Okay, and we say voltage drop is V1 here, voltage drop is V2 here. So they say find V1 and V2 for this circuit. And now I'm changing this circuit a little bit here. This is plus minus 20 volt. Okay, and this is same 2 ohm. Find V1. Okay, and this is 3 ohm. Okay, now I'm saying instead of measuring like this, you measure like this. Okay, this is my V2. I'm measuring like this. Okay, so tell me what is the value of V1 and V2. Okay, in both the cases. So V1 is, so if first I would define the current in the circuit. See, let's say current is I. Once I have defined the current, okay, I can easily find what is V1. So V1 will be simply I into R. That will be 2I. And your V2 will be what? V2 will be your 3I. Okay. Now apply Kirchhoff voltage law. So I can write apply KVL. If I apply KVL, I can write minus 20. Okay. Plus V1 plus V2 minus plus V2 equals to 0. So that gives me V1 plus V2 is equals to 20 volts. Okay. So V1 plus V2, this is 20, and V1 is what? 2 into I. So this is 2I and this is 3I equals to 20. Okay. 2I plus 3I equals 20. So from here, you can calculate the current. Okay. So this implies current 5/20. So I is equals to 4 ampere. Okay. And once you know the current, you can find the V1, V2. So V1 will be 2 into I, that is 2 into 4, 8 volts. And your V2 will be 3 into I equals to 3 into 4, that is 12 volt. Okay, so voltage rise, the battery is 20 volts and this 20 volt is getting drop here. Okay, 8 here and 12 here. So sum is 0. Sum of voltage is 0. Okay, now here same thing here. Here you have to change little bit. You want V1. So V1 will be again, if you define the current I, this is 2I. Now V2, if I want to write V2 here, okay, minus 3I, very good. Okay, because we are Ohm's law will be not changed. You have to change, you have to take care of sign. Whenever you moving, I told you yesterday, whenever you moving like this, okay, so your Ohm's law is now minus IR, not VIR. Okay, now you have minus 3I, V2 equal to minus 3I. Okay, now again you can apply same thing, KVL. So minus 20 plus V1 minus V2 equals to 0. Okay. So V1 minus V2 will be 0. So V1 is your 2I and this is your minus 3I. So minus 3I equals to 0. Current again comes 20. Current again comes 4 ampere, but this time your V1 will be 8 volt and your V2 will be how much? Minus 12 volt. Okay. So in this way, you have to solve the circuit. Okay. The sum of voltages rise 20 and minus 12. So voltage rise is 8 volt and voltage drop is also 8 volt. Okay. This minus voltage rise is 20, voltage rise is minus 12. Total is 8. Voltage drop is 8. So sum of voltage rises equal to sum of voltage drops. So sign convention, you have to always take care while solving this Kirchhoff law. Okay. So now you are familiar with this law. Let us solve some problems. Any question? While for applying, or are you comfortable with this one? Okay. Now let us solve slightly problem of higher order or higher complexity. I have been given this is plus minus 60 volt. Okay. This is your 8 ohm. This is your 10 ohm. This is your 4 ohm. And आपको निकालना है, you need to calculate this Vx. What is the voltage drop here? Vx, and this resistance is given 2 ohm, and this is your Ix. Okay. So these both are parallel. So here also voltage drop is Vx. Okay. And you have been given also the current is coming is here 5 ampere. Okay. So solve, tell me what is Vx. Okay. So if in a loop there are 3 voltages, okay, if you want to find an unknown voltages, at least you should know 2 voltages. Yes or no? Okay. So in this way you have to look the circuit, okay, which voltage is known, which is unknown, then which is okay. Then loop wise you have to move one by one. For example, here this voltage, there are 3 voltages, 1, 2, 3. If I apply KVL, okay, so this voltage I know, this voltage I know, but this voltage I don't. This voltage I know, you know this voltage or not?
Yes, sir, 40.
40. So this 60 you know, this 40 you know, 5 ampere current. So 60 and 10 voltage rise, voltage drop. So you can know what is voltage here. Once you know the voltage here, you know the voltage, you know the resistance, you know the current here. So 5 ampere current here, some current is going here, remaining current is going here. Remaining current you know voltage, you know voltage now here, you know voltage now here. You can easily calculate what is voltage at Vx. Okay. Please calculate and tell me what is the voltage of value of Vx. So this is your 60 volt here. This is the 8 ohm resistance. So the voltage will be 40 volts. I into R. Okay. So now you apply KVL here. You can say voltage across V10 ohm. What is V10 ohm? So you can write a KVL here minus 60. Okay. Plus 40 and plus sign intervention V10 ohm will be 0. So V10 ohm is equals to your 20 volts. Okay. So this is 20 volts. Okay. Now you know this 20 volts. Okay. Now current, you can find the current. What is current in I10 ohm? So current in 10 and V voltage is V and current is resistance is 10. So you have a 2 ampere current. So out of 5, 2 ampere current is coming here. Okay. Now apply KCL. So 5 out of 3. So remaining 3 is coming here. Okay. So voltage drop here become again 12 volts. 12 volts. Okay. Now you can apply KVL in loop 2. So this is loop 1. Now in loop 2, you can apply KVL. So you move like this. Okay. So you can write minus V10 ohm plus 12 volt and plus this Vx. Okay. Plus this Vx equals to 0. So minus V10 is, 20. This is minus 20 plus Vx 0. So your Vx will be how much? 8 volts. Okay. This is your answer. So one thing I want to tell you that in the classroom, it is not possible to solve so many problems. Okay. So what I'll do, I'll give you some problem as a homework, and for some problems, I will make separate videos. Okay. So so you have to note down this everything in your notebook, in your notes copy, and I will send you some separate videos also. Okay, some 15 minutes after each class. That video also you have to see, and that notes also you have to put in in your notebook. Okay, because 1 hour class I cannot solve a lot of problems, so that's you have to manage the time. Okay, if you want more practice, then you have to see separate videos also. Is this point clear? Okay, so if you problems, I will solve the problems and I will send you the link of video, and that you have to see and note down all the things in your notes copy also. So this is your Kirchhoff voltage law. Okay, now take a homework problem. Plus 30 volts. Okay. And then you have this is 10 ohm, 8 ohm, and 2 ampere current is flowing here. Okay, and this is your resistance of 2 ohm, and this is resistance of 2 ohm. Okay, here again same current source is there. Okay, and this is, you need to find this Vx. What is the voltage across this current source? So 10 to 8. This is your homework. Okay, find Vx. Note down this problem and send me the solution. Okay. Any question? So so voltage division in series resistance. Okay, voltage division in series circuit. Okay, so we have say n number of resistors. Okay, are connected in series. Say this is my R1, this is my R2, this is my R3, okay, and so on. So this is my Rn, and here I am applying a voltage source V plus minus. Okay, so voltage drop here is V1, voltage drop here is V2, voltage drop here is V3, the voltage drop here is Vn. Okay, now I want to find what will be the value of V1, V2, V3 when they are in series. Okay, how this voltage will distribute among this resistors. Okay, so I can apply KVL in the loop. Say the current is I moving clockwise, so apply KVL. Okay, so if I'm moving like this will be minus V. Okay, and this will be your V1 plus V2 plus V3, so on Vn equals to 0. I can write my V equals to V1 plus V2 plus V3 equals to Vn. Okay, now if I current is flowing here, okay, and so what is V1 first? So V1 I can write I current is flowing, so I into R1. Okay, similarly V2 is your I R2. V3 is your I current flowing across resistance R3, so this is IR3. And I current is same in series. Okay, current is always same in series, so this will become your I Rn. Okay, and this gives me I R1 plus R2 plus R3 Rn. Okay, now if I write this V, the equivalent resistance of this circuit as a R equivalent. Okay, so my R equivalent will become R1 plus R2 plus R3 equals to Rn. Okay, so from here I can calculate what is the value of current. Okay, so current will be basically what is the value of current now? So I know this is R equivalent is R1 plus R2 plus I3. Okay, now if I want to calculate the current, I simply have to divide V by R equivalent. Okay, so if I want to calculate V1 in the circuit, yes, any question? Is there any question? Okay, so now I will be simply V upon R equivalent. Okay, now if I want V1, so V1 will be what? V1 will be your, I'm audible? I'm audible?
Yes, sir.
Yes, sir. Yes, sir.
So V1 will be your I into R1. Now I, you know, okay, V upon R equivalent, okay, into R1. Similarly, you can find now V2. V2 will be your V upon R equivalent, that's R1 plus R2. Okay, let me expand this one. So basically, you will be, if you want V1, then you have to find this ratio R1 plus R2 plus R3 Rn, and accordingly resistance your voltage will divide, total voltage will divide. Okay, similarly you can write V2 equals to R2 R1 plus R2 plus R3 Rn, okay, into V. Okay, and in general Vn will be resistance, your resistance where you want voltage, total resistance, okay, Rn, and total voltage B. So in this way you can, the voltage will distribute according to the magnitude of resistance, okay, of resistor. So for example, now let me give some values to this resistance. Okay, so suppose I have a resistance, this is 2 ohm, this is 3 ohm, and say this is 5 ohm. Okay, and I have a battery of 10 volt. Okay. Now this 10 volt will be divided across these resistances, okay, according to their value, magnitude. So if I find the current in the circuit, okay, current in the circuit, so current will be what? Current will be V, total and total R, or R equivalent, okay, and R equivalent is what? 2, 3, 2 plus 3 plus 5, and the value of V is 10, okay. So this 10 plus 10, the current value is 1 ampere, okay, current value will be 1 ampere. Now this point, so here voltage I have 10 volts, so here voltage is 10 volt, okay, connected to this battery, okay. Now I current is flowing 1 ampere, so here will be voltage drop of 2 volts, 2 into 1, so voltage drop will be here 2 volts, remaining 8 will come here, okay, remaining 8 will come here. Now again 3 volts will be divided here, 3 volts will be divided here, okay, 3 into 1 current, so remaining 5 come here, and 5 into 1, 5 volts will be divided here, remaining here could come 0. Are you getting this one? Total 10 volts. So this point is a higher potential 10 volt, and this is a lower potential 0 volt, because there is a potential difference, okay, here and here. This and this point same, this point same, this point same, because there's a potential difference, that's why current is flowing in the circuit, okay. And then 10 volts, 2 drop, remaining 8 volts here, 3 drops, 3, remaining 5 here, 5 here, remaining 0 here. So this is this way you can understand the how voltage gets divided in series, okay. Now let us do current division in parallel circuits. So this we are solving just using basics law, okay. We are not going any technique in any higher order technique, okay. So now put here current in parallel circuits, okay. Current division in parallel circuits. Current division in parallel circuits. So say we have a n number of resistance connected in parallel. This is R1. This is Rn, R1, R2, R3. Okay. And here say a voltage source is there which is giving current. You can put a voltage source here. I am putting current source, no issue. Okay. Current is coming I, total current is coming I. Okay, this is I total. I is coming here. Total current I. Let me write I total. Okay. Out of IT, some current is going here, say I1, some current is going here I2, some current is going here I3, and some current is going here, say, let us say this current is IN. Now I want to calculate what is the value of I1, I2, I3. Okay. So you know the voltage, or you can put here voltage, saying if you want to show the voltage is same here. Okay. So we know this all our resistances are parallel. So voltage drop across each resistance is same. Only current is different. So current divides here. Voltage is same. So if I want to write here, apply KCL, which is one single node. Okay. So this all are connected on one node. So apply KCL. We apply current. KCL says I total is equals to I1 plus I2 plus I3 plus IN. Okay. Now I1 is voltage divided by resistance, and voltage is same across each, equal to V, and resistance is R1. Is voltage is same, resistance is R1. Voltage is same, resistance is R3. and so on. You can write voltage upon Rn. Okay, this is your I. Okay, so what I can write? I can write I total equals to V. I can take common. This become R1 plus R2 plus R3 Rn. Okay, and this I can write what? IT, total current, total voltage is V and R equivalent. Okay, so V equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3, 1 upon Rn. So V cancel. So you get 1 upon R equivalent. Okay, 1 upon R equivalent will give you 1 upon R1 plus 1 upon R2 plus 1 upon R3 and 1 upon Rn. Okay. So now you have R. Now I want to find what is the value of I1, I2, I3, I4, In. How current get divides. Okay. So now write the value of I1, I2, I3. So how can I write the value of I1, I2, I3? So if I want to write what is the value of I1, okay, what is the value of I1? Okay, so I1 is simply V upon R1. Okay, and V is the thing that is equals to I into R equivalent. Okay, yes or no? Can I write like this?
Yes,
R
sir.
equals to R1. Okay, and similarly, if you want I2, you want V R2. Okay, V R2, and this will be I R equivalent upon R2. And if you want IN, that is V upon R3, that is I R equivalent upon R3. Okay, so in this way you have to calculate the equivalent resistance. Okay, and you can find the current in each resistance. Okay, now generally in this course, okay, that will several times we will see this current division will come whenever I will solve the circuits. Okay, solve the circuits, or when we use diode, transistor, op-amp. So this is very useful. Okay, current division. So you have to apply this. You have to learn how to apply current division. Okay. For example, here is the N resistance. I am solving this for simple 2 resistance. Okay. So for two simple resistance, 2 resistance case will come again and again. So let me show if only there is a 2 resistance in the circuit, then how to apply current division. So say only there are say some voltage is there, and say only I current is coming, and this I current is getting divided in this resistance R1 and this resistance R2. Okay. Now I want to find what is the, say I1 current is flowing here and I2 current is flowing here. So what is the formula I will use? Okay. So again, if I want I1, that will be V upon R1. Okay. And V is again I, total current I into R equivalent upon R1. And R equivalent value is what? 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. So that gives me R equivalent value as R1 R2 upon R1 plus R2. Okay, put this value here. That will give me the current value I. This is my R1 R2 R1 plus R2, and already R1 is there. So R1 cancel. I got I equals to R2 R1 plus R2 This is my I1. Okay. Similarly, if I want I2, so I2 will be my same way I can do. Okay. So instead of, if I do solve this one, this will come out I R1 plus R1 plus R2. Okay. Now you have to get familiar with this one. If there are two resistance are in parallel, okay, this is resistance 1, resistance 2. There can be more than two resistance also. Okay. And so if the resistance are in parallel, so you have to see how current divides in parallel circuits. Here one resistance, two resistance, here maybe one more resistance. Either R2 can be, you can be R2, R3 also. But you have to see in two branches how current get divides. So if you want to see how current divides in two branches, if you want the current in this branch, you have to take opposite resistance. Okay, what is resistance here? Resistance R2. Total current. You want current here. See resistance of opposite resistance R2 and the sum of resistance. Sum of resistance, not equivalent resistance. Equivalent resistance is different. Okay, equivalent resistance means whether it is series or parallel. You have to take sum of resistance. So total current into resistance opposite R2 and the sum of resistance. This will be R1 plus R2. Similarly, if you want current in this second branch I2, then you have to see the resistance of opposite branch. Resistance opposite branch is R1 and then sum of resistance and total current. So this way current gets divided when there is a two branches. Okay, in two branches resistance can be many. Okay, but how current branches in two branches, that you have to understand. Okay, now let us show me this one with one problem. So if 5 ampere current is coming and that is current is getting divided in two resistance which are in parallel. Okay, so parallel voltage will be always same, you understand. So this is 10 ohm resistance and this is your 15 ohm resistance. 5 amp current is coming. You have to calculate what is I1 and what is I2. Tell me what is I1, I2.
Three and two, sir.
Any other person? So I want I1. If I want I1, so then what is the formula? Take light first, total current IT, resistance of opposite. So this is R1, R2. Total current is your 5, resistance of opposite 15, and the sum of resistance 25. So 1, 5. This give you 3 ampere. If I want to write I2 means total current, opposite resistance 10, and then sum of resistance. I'm again repeating, this is sum of resistance, not equivalent resistance. Sum of resistance, this will be how much? 25, 1, 5, this is 2, this is 2 ampere. Okay, the total current is 5 and current dividing as a 3 ampere here and I2 5 and 2 ampere here. Total current is same, KCL. Okay, so this is a current division. Okay, now let me slightly modify this circuit. Okay, same circuit I'm a little bit modifying, and then you have to tell me now what is I1, I2. Okay, the same circuit I'm modifying now. Say this is 5 ohm here, 10 ohm here. Okay, so I1 is coming here, I2 is coming here. So whether the value will I1, I2 change now or it will remain same? The value of I1, I2 will change now or it will remain same?
Changes, sir.
Changes. Okay, any other person?
It will change.
It will change. Oh, how? Why it is changed? I repeated 3-4 times one sentence. I think you're not properly hearing.
No, sir, same.
Same. Why it is
Because
same?
some of the resistance are 25.
Yes,
Again.
very good. Branches are, what do you see? Branches are how many? This is one branch. Yes or no? And this whole is second branch. This whole resistance, this sum of this resistance is parallel to this one. So this is a one branch, and this total is a parallel branch. Are you getting this one? So just whether I write 25 here or 5, I repeat, I distribute 5, 10. That is same thing, na? Resistance same. I can again put a equivalent resistance of this one, 5 amp, and I can put this. This is my 10 ohm, and I can put this is now 15 ohm. This is same thing. They are series. The current is coming here. Current, the same current is flowing in the circuits. When same current is flowing in the resistors, that means they are in series. Okay. So this is the same circuit. So the current will be same. Okay. Here also will be same current flowing. Here also same current flowing. I1 was 3. Here 2 ampere. Here 2 ampere. Here. So that's why I'm telling you to understand. Branch. How many branches are there? So there are 2 branches of there. One branch, and this whole is one branch. Okay. And the sum of resistance is same. In this branch, resistance 10. In this resistance is 15. So accordingly, you have to apply this law. Okay. Now let me increase the branches. Okay. So you have now 3 ohm resistance. You have here 6 ohm resistance. Here you have 9 ohm resistance, and you have here 12 ohm resistance. Okay. And again 5 ampere, 5 amp current is coming here. Okay. Now you divide this current. Say current here is I1. In this circuit, current is I1. Here current is I2. Here current is I3. Here current is I4. Okay. And these all are grounded. These all are grounded. Now calculate I1, I2, I3, I4. How will you calculate? What is the formula now you'll use? Okay. I'm giving you 2 minutes time. Okay. So how should I calculate? Tell me. What is the formula I should use? So suppose if I
The
want,
first formula, I into R equivalent by R1. That one to calculate the I1.
very good. Okay. So I want, if I want, so I will be total current IT into R equivalent upon R1. Okay. Now R equivalent is what? R equivalent to calculate 1 upon R equivalent is equals to 1 upon R1, 3 plus 6 plus 9 plus 1, 12. Okay. So how much will come? Tell me. So what should I write? 24,
6 upon 25.
36, 36, 12 plus 6 plus 4 plus 3.
3.
Okay.
25
So
by
this
36.
is 18 25. Okay. So
By
R equivalent will be 36 upon 25.
35.
Thank you. So now once you know this one, you can quickly find I1, I2. So I will be total current is 5, resistance is R1 is 3, and the 36 by 25, that is 1, 5 is 12. So current is 12 by 5 ampere. Okay. Similarly, if you want I2 will be total current, always a total current first, then R equivalent 36 upon 5, 25, and the resistance 6. So 6 cancel, 1, 5, 6 by 5 ampere. Similarly, if you want I3, total current 5, R equivalent 36 upon 25, and 9. So 1, 4, 5. So this is 4 by 5 ampere.
I4 is equal 3 by 4.
I equals to 3 by 4. Okay. So 5 upon 12 into 36 upon 25, 3,
5.
5. Okay. So 3 by 5 ampere. Okay. Now if you sum all this I1, I2, I3, it should come 5 ampere. Okay. So in this way, you can apply current division in the circuit. Okay. Now, so this was just, we have learned so far only basics law. Okay. Now we will learn techniques. Okay. Now techniques will help us to solve circuit. Okay. In quick time. So one technique which is we are going to start first, that is nodal analysis. Okay. We are going to learn two techniques. One is mesh analysis and other is a nodal analysis. So put the heading now, nodal analysis. So right before I tell you what is nodal analysis. Okay. So nodal analysis basically is the combination of KCL plus Ohm's law. Okay. You just note down the steps. What are the steps of these techniques? Okay. So number one step is there. Identify node. Okay. Identify nodes. Okay. And assume there are n nodes. Assume there are n nodes in the circuit. First, you have to find how many nodes are in the circuit. Step 2 is you have to write, assign one node as a reference node. Assign one node as a reference node. And the third point is, okay, apply KCL at each node. Apply KCL at each node. Okay, except reference node. Except a reference node. Okay, and the fourth point is, when you write the KCL at each node, you get some equation. Okay, solve simultaneous equations. Solve simultaneous equations. Okay, solve simultaneous equations and calculate node voltage and calculate node voltages. Okay, and once you know the node voltages, then you can find the branch currents. Okay, calculate node voltages and find branch currents. Find branch currents. Let us understand this technique. by example. Okay, so I am taking a previous year exam question. So
सर ये साइमल्टेनियस में क्या लिखा है?
simultaneous equations.
ओके सर.
तो मैं एक प्रीवियस ईयर का क्वेश्चन ले लेता हूँ जो एग्जाम में भी आया है, तो उससे आसानी हो जाएगी आपको समझने में. One minute. Okay. ना मैं 2-3 क्वेश्चन करूंगा इसके. ओके, आपको अंडरस्टैंड करना है, बाकी मैं इसका वीडियो बना के भेजूंगा आपको. तो अभी इसको करना है, और जो होमवर्क दूंगा उसको आपको प्रैक्टिस करनी है. सो के 2007. So the problem came, you have 38 volt and you have 5 ohm resistance, and then you have 4 ohm resistance, 2 ohm resistance, and then you have 76 volt. Okay, and this is your RL. So in question this says find the voltage across RL. Find the voltage across RL. So now you need to find the voltage across RL. Okay, so first of all, this technique says, you read the steps. The number 1 step says, okay, identify the nodes. How many nodes are there in circuit? Tell me how many nodes are there in the circuit?
4, 4, sir.
4. Okay, this is one node, this is second node, this third node, and this whole is a one node. Okay, this whole is a one node connected to ground battery. Okay, now the step first says identify the nodes. Okay, then select. Now 4 nodes. Now select one node as a reference node. Okay, so which node should I take a reference node? Reference node, which a node generally has a 0 voltage. Okay, so you can choose principally any node out of this 4 as a reference node, but try to select a node which has a which is covering multiple terminals as a reference node. Now because this is the connected to the ground and covering multiple terminal, so I am taking this as a reference node. So this reference node has a voltage 0. Now with respect to this node, I want to find the voltages of these nodes. Okay, so already this is 0 and this node is already 38 volts. 38 volt. This node is already 38 volts, and if I say this node is already 76 volt voltage, so the unknown voltage is only this one. I know this node voltage, and this node voltage. So unknown voltage is only one. That means only I need one equation to solve this circuit. Okay. So this is the unknown voltage. This voltage I want to find. So I would write the KCL. The third step says write the KCL. So KCL I will write here. Okay. Now, how do I know how many currents are coming here? So there are 3 branches. There will be 3 currents. Okay. Now, what should be the sign of the current? That is totally depends on you. Okay, you can choose any direction the current. Okay, later KCL will tell you the right direction. Okay, so that is your choice. So I generally take all current as a outgoing current. I take all the current as a out. So this is my I1, this is I2, and this is I3. Are you getting? These 3 nodes, 3 currents are dividing. I am telling all the currents are outgoing. Now, if you want, you can take all the current incoming. You want, you can take 2 currents outgoing, one outgoing, one coming incoming. You can take 2 currents outgoing, 1 currents outgoing. That is totally your choice. Okay, you write in any way. Nothing will answer become same. KCL will take care of direction also. Now you want this I1. So you have to write the KCL. So apply KCL at node A. Apply KCL. Very simple technique. Apply KCL at node A. Okay. Now node A, sum of incoming currents equal to sum of outgoing currents. So I am telling all the outgoing. So my I1 plus I2 plus I3 should be 0 because there is no incoming current. You can put I1 plus I2 equals to I3. That is also your choice. Okay. Now I am taking outgoing current, all the current outgoing. So, and I'm taking outgoing current as a positive. Okay. You can take anything. You can take incoming current positive, outgoing current negative. Okay, I am taking outgoing current as a positive, incoming current as negative. Incoming currents are not there here, so that is 0. Okay, the sign you have to take care. Whatever sign you put here, accordingly you have to act. So this is the outgoing current. So I want I1. So what is the value of I1? Tell me. Someone tell me what is the value of I1? Any new students which have not done this?
Minus 38 by 50.
5. Okay.
5.
So I1 is what? Voltage difference divided by resistance. Current is what? Voltage difference. That I1 is VA minus 38 divided by 5. Okay. I2 will be what? I2 will be VA minus 76. 76 divided by this 2 ohm. And I3 will be VA. This is 0. This whole is 0. VA minus 0 upon 4. So this is my I1 plus I2, I3 value. Put here, solve this and find out VA. Tell me what is
Sir?
VA?
48 volt.
I have a doubt, sir. Here we take I1 is a outgoing current. I1 is incoming current and I3 and I2 are outgoing current.
All are outgoing current. All are outgoing current. So I told that's what I mean. There is no KCL will take care of everything. Now you want to put whatever you want to put. You put anything. Incoming current, outgoing current. There are 3 currents. Now you want to put in one is outgoing, 2 is incoming. You can do that one. But then you are putting incoming and outgoing both the type of current. Then you have to tell me you have to choose which current is positive, whether outgoing is positive or incoming is positive. That is also your choice. Are you getting?
Yes, sir.
You take any random things. Okay. So in KCL, there are the incoming currents and outgoing currents. Okay. Algebraic sum should be 0. Then it means some current you have to take positive, some other you have to take negative. Incoming positive, outgoing negative, outgoing positive, incoming negative. The sign you have to choose. Okay. And accordingly, you have to write the KCL. So nothing will change. Now you can solve the circuit some other way also. Okay. So for example, if I'm showing, if I say cell I1 is incoming, let me say I1 is incoming. Okay. Now you're happy? I1 is incoming. So now incoming current should be equal to outgoing current. Okay. So that will be equals to what? KCL I1 plus I1 equals to I2 plus I3. Yes or no?
Yes, sir.
But now that means that is minus I1 plus I2 plus I3 equals to 0. Yes or no?
Yes, sir.
Yes. So now if you put this is a incoming current. Now what will come? Let's come now 38 minus VA. 38 minus VA upon 5. Okay. Already minus is there. That means same, na?
Yes, sir.
So either you take I1 incoming, that will nothing will change. This will take care of. Now I1 is your 38 minus VA upon 5. Minus is there again. This becomes same. VA minus 38. Okay. So that is your choice. Okay. Let us put like this. What is the issue? Okay. So this is incoming current. I'm taking negative, outgoing current and positive. Okay. Now I have to change the expression for I1 if you want. So I have to change the expression for I1. So now my I1 will be, because it's moving like this. So I will write I1 equals to 38 minus VA upon 5. Okay. So now put the values and calculate. So and tell me what is the answer is coming. What is the value of VA? Someone told 48 volts. Please other check is coming or not.
Yes, sir.
Okay, so let me show you here. So minus 38 minus VA upon 5 plus I2 is VA minus 76 plus I3 is your VA upon 4 equals to 0. Okay. Now if you solve this one, this should come like this. Equation, one voltage, one unknown, one equation. Okay. So that you can do it. Let me give you one more problem. I'm giving you a simple problem. Okay. Plus minus. This is 2 ohm. This is 2 ohm. This is 1 volt. Okay. This is 1 ohm. This is 3 ampere current is coming here. Okay. So this is 1 volt. This is okay. So this voltage is already known. And here you have a 1 ohm resistance here. Okay. So 3 ampere current is going here. So that means here also you know the voltage drop. Okay. So voltage drop, you know, so you already know this current, one current already know. So you want to need to only 2 currents. Okay. So this is your, so find the VA. Okay. Say find VA. Now you don't require voltage here. Okay, because you already know the current here. So you need voltage only to calculate current, so you already know the current. Okay. Now you put randomly whatever current sign. One is incoming, so let it be incoming. Say one is incoming. And other you want to, if you want to find incoming or outgoing, whatever you want to put and solve this. Tell me what is VA value. Only take care of sign. Choose your method, your own method. Yes, 3.5 volt आएगा. Very good. Okay. So say all currents are outgoing. You can take whatever. Okay. So I1, I say I2, this is I2, and this is I3. Okay. So I can write KCL. So I'm taking outgoing positive, incoming negative. So minus I2 plus I3 equals to 0. Okay. Now what is the value of I1? So I1 is for me this one, VA minus 1. Okay. VA minus 1 upon 2 ohm. I2 is for me 3 ampere already given, so no need to calculate. And I3 for me is VA minus, this is 0. This is a reference node. Okay. This VA minus 0 upon 2. Okay. Put value here. VA minus 1, 2 minus 3 ampere current plus this is VA minus 0 upon 2. Okay. Take 2 as LCM. So this VA minus 1 minus 6 VA minus 0. Okay. Equals to 0. Okay. So 2 VA, this implies 2 VA equals to 7. So VA equals to 3.5 volt. Okay, so once you know the VA, you can also find the current in the circuit also. So now what will be the I1? Put the value here, I1 value. Okay, so I1 will be your 3.5 minus 1, 2.5 upon 2, that is 1.25 ampere. So I2 is already known. I3 means 3.5 minus 2, that is 1.75 ampere. Okay, so 3 ampere is coming here, 1.24 going here, 1.25 and 1.75 is going here, total 3 ampere. So that way you can also check. Okay, this sum should be 3 ampere. So the purpose of nodal analysis is to find the voltages and branch currents. Okay, you can easily do this method. Okay, so this is so far what we are doing nodal analysis जहाँ पर क्या है हमको खाली एक ही voltage unknown है. So we are getting one equation and we are solving very easily. If there are the two nodes, okay, unknown, then you will get two equation. If three node unknowns, you'll get three equation, and so you have to simultaneously solve this equation and you'll get the voltages. Okay, so let me do for one question for two where we have two voltages unknown. Okay, and before that just write one homework. So you have 32 volts. Okay, and you have this is 4 ohm. Remove this all things signs. You have 4 ohms. Okay, this is your 12 ohm, and this current is given as a 2 ampere. Okay, and here there is no resistance. Okay, 4 ohm, 12 ohm. Okay, 32 volts. Okay, so find VA. Okay, that is your homework, and I'm giving you the answer also. You have to send me the solution. Okay, so VA will comes out 30 volts. Six ohm, 4 ohm, 2 ohm. Okay, and here is current source is given equals to 5 ampere. Okay, and now solve. Okay, find the voltages. Okay, now first tell me how many nodes are there. How many nodes are there?
1, 2,
So this is
four,
one.
sir.
This is one node. Okay, and this is one node. This is one node. Okay, so here current is already given, so you don't need to worry about this one. Okay, now you don't know what is the voltage here. Until you don't know voltage here, you cannot calculate what's current here. Similarly, if you want to find current here, you need voltage here. So you need these two nodes, V1, V2. Okay, once you know the V1, V2, you can solve all the circuits. Okay.
Sir, can you say one thing?
Tell me.
Can you say once, please, sir?
See this, if you want to find current here, this is reference node 0, this V1 minus 0, you can calculate the current. First you need V1, na? V1 you don't know. Here also you cannot calculate current until you don't know this voltage here. Once you know this one, you know this one. This already you know current, here you know already current. Okay. So the purpose is to find the branch currents. Okay. So how many nodes are required? This voltage I don't know, this voltage I don't know. Apply KCL at each node and find the V1, V2. Now there will be two equations, and simultaneously that two equations you need to solve. Solve and tell me what is coming. Write two equations and solve. So first node, okay, say current, I say I1 is going here, I say I2 is going here, and this current is coming, say I3 current coming here. Okay, now same current I2 is going here. Okay, and one current is going from here. Okay, so this is I3. This is the same current which is going here. So this is I3. Don't give two names to one current. And here I2 is coming, I3 going. Say this is I4 is going here, and say this I5 is coming here. Okay. Now say no, this is node A1. Say node A. Say node this B. So apply KCL. Apply KCL at node A. Okay. Now at node A, how many currents are there? I1, I2, I3. Okay. How many are outgoing? One is outgoing. So I take outgoing positive. I take incoming negative. So I2 negative, I3 negative. Now that is your choice. You can take I1 as a negative and I2 is positive. Okay. Now what is I1? And similarly apply KCL at node B. Apply KCL at node B. Okay. So node B, how many currents are there? I2 is coming. So and I4 is, so I2 coming, I2 is negative for me. Okay. I3 is going, so I3 is positive for me. You can take opposite. I4 is going, I4 is positive for me. I5 is coming, so I take incoming negative, so I5 is negative for me. Okay. Now just find the value of I1, I2, I3 and put here. You get two equation and you need to solve that one. Okay. So what is
first equation? I3 will be positive. Now it is coming towards the node. No?
So incoming current I'm taking negative, na? Incoming current I'm taking negative.
Yes, yes.
Okay. Incoming I'm taking negative. So now what is the value of I1? So I1 value is, tell me what is the value of I1? V1. Tell me what is the value of I1? V1 minus 0 upon 2. What is the value of I2? What is the value of I2? Someone tell me. What is the value of I2?
V1 minus V2 by 4.
Very good. And I3 is already given 5 ampere. 5. Okay. So this will give you one equation. Put here. So you got V1 by 2. Okay. Then minus V1 minus V2 upon 4 and minus I3 is 5. This give you one equation. And similarly, if you write here I2 minus, I2 is minus and I2 value to already have written, I3 is there, I4 is this one, V2 minus 0 upon 6 ohm, and I5 is already given 10 ampere. So I5 is 10 ampere. Okay, put value here.
Sir,
Uh,
sorry for interrupt, but I2 is going out and in the diagram, I2 is going out and I1 is going out. Na?
uh.
So I should be positive. So I2 should be positive. Na?
So I2 is, yes, I2 should be positive. I2 is outgoing. Very good. I1 is going out. I2 is going out to positive. I3 coming. I3 negative. Correct. Okay. Very good. And second में क्या होगा? I5 is incoming. I2 is incoming. So they're negative. I3 is outgoing. I4 is outgoing. So they are positive. Good. Okay. Now put here I2. I2 is your V1 minus V2 upon 4. Okay. Plus I3 is 5 plus I4 V2 upon 6 and I5 is 10 minus 10. This will give you second equation. Okay, so tell me what are the equation you're getting. If I write this equation 4, this will be 2v1 plus 3v1. This equation gives you 3v1 minus how much? 2v1. ये equation क्या देगी बताओ? 3v1 minus v2, huh? 3 minus v2 equals to 20. This will be your first equation. And if you solve this equation, this should give you, if I take this 4, 24 or 12, if I take 12, it is 3v1, okay, very good. 3v1 will come 3v1 and this will come v2, 3v2 and this is 2, 5. Okay, so tell me what is the this equation I should get. This will be plus 5, so minus 560. Okay, so I'm writing the equation. You tell me whether correct or not. Okay, you have to find. So minus 3v1 plus 5v2 equals to 60. I should get. Check it. Tell me.
Yes, sir. Yes.
Very good. Okay, now just you need to solve this equation and tell me the answer.
V1 10 by 3 or V2 minus 10.
No, थोड़ा calculation में mistake हुआ है. V2 is 20 and V1 is 40 by 3.
Yes, sir.
Sir, V2 equals to 20.
20 आ रहा है सबका?
Yes, sir.
Okay, V2 20 and V1
40.
40 by 3 volts. Okay, so your V2 is 20 volts and V3 is 40 by 3 volts. Okay, so ये टेक्निक बड़ी सिंपल है. अभी कितने भी चीजें पता नहीं हो, now you know all the voltages, you can find all the branch currents. Okay, so that is your homework, calculating branch currents. Okay, that is your homework. And then you can check 5 coming, so how many going here, how much going here. You can verify also. Similarly here you can also verify. Okay, how much coming here, how much going and how much coming here. So you have to calculate I1, I2 branch currents also. Okay, so this was the method where we have 2 unknown things. Okay, now if there are more than 2, suppose there are 3, that also you can also solve. Okay, so I'm giving you a question. If you're interested, you can solve, and I'm giving you the answer also. this is 5 ampere current coming. Okay, this is your 20 volts. This is your 3 ohm. Okay, this is your 1 ohm. And this is your 2 ohm. Okay, and this is your 5 ohm. Okay, so 5 ampere, 1 ohm. This is your 6 ohm here. 6 ohm, 1 ohm, 6 ohm, 5 up to 3 ohm. Okay. That is correct. Okay. So this is the question. And you tell me unknown, tell me the unknown nodes, how many nodes are there and how many unknown voltages are there. Okay, tell me. How many?
बीच में से वो क्या रजिस्टर की वैल्यू है 6 ओम है
6 ohm है.
Okay.
6 ohm है. So tell me how many nodes are there. Tell me first. And which किसकी पता करना है, किसकी पता नहीं करना है. So this is the one node. Yes or no? This both are same node. Node 3 and this is node 4. Okay. So if I want current here, I should know voltage of this one. If I want current here, I should know the voltage of this one. So this voltage also, this voltage I should know. So I should know this V1. So this is V1, this is both are same. This is already known. No, this is not known, unknown. Okay. So this is unknown V1. Okay. Then say this is my V2, this is my unknown, and this is V3. These are 3 nodes, and this is a node, this is already known. Okay. So find out V1, find V1, V2, and V3, and answer I'm giving you. You can verify by solving. Okay. So V1 is 23.82 volts. Okay. V2 is 27.4 volt, and V3 is 19.04 volt. 19.04 volt. Okay. So this is your homework.
सर वहां पे भी होगी एक नोड
कहाँ पे?
रेजिस्टेंस एंड 20 वोल्ट.
कहाँ पे?
That
20 volts ना?
yes.
यहाँ पर? यहाँ तो कोई नोड है नहीं ना? कहाँ नोड है? ये तो पूरा वायर है. ये नोड कहाँ होता है? जब जहाँ 2 ब्रांचेस मैच करती है. तो ये ब्रांच है. अब ये वाला बोल रहा है, ये वाला कौन सा नोड बोल रहे हो? ये वाला बोल रहे हो ना?
तो यही पूछ रही हूँ यहाँ पे होगी या नहीं होगी.
क्या हो गया?
एलिमेंट्स तो अटैच हो रहे हैं.
नोड तो है, ये नोड तो है, बट ये ऑलरेडी नोन है ना. ये तो 20 से कनेक्ट, तो 20 से नोन ही है ये.
यस सर.
जरूरत नहीं है हमको.
सर जहाँ पे आपने V2 लिखा है वहां पे नोड नहीं होगा.
कहाँ पे?
जहाँ पे आपने V2 लिखा हुआ है वहां पे नोड नहीं होगा.
ये नोड है ना
जी.
ये तो नोड है ही. V2 V1 V2 V3 नोड है आपका. जहां पे भी 2 ब्रांचें मर्ज करेंगी, देयर इज अ नोड. ये भी नोड है बट नोन है, तो उसको ड्रॉ
I
करना.
have a doubt, sir.
हाँ
At V1,
हाँ.
another branches also is also.
This whole is one branch. This whole is one branch. This whole is one node. So this is a point. This is one terminal. This is all is one terminal. This is one terminal and this one terminal. You have this component. So this is a node. Okay. This whole is a one node. So I am taking this is, you can take reference node. This one also reference node. This one also reference node. Okay. So I am taking this as a reference node. You can choose any node as a reference node. No issue. Answer will come same. Bulila, what is the problem now?
Yes, sir. I got it, sir. Now I clear.
Okay. So I'm stopping here. Okay. If you have any question, please ask. Otherwise, any question? So if no question, हाँ?
V3 का लिखा है.
V3 निकालना है ना?
आंसर में.
आंसर में 19.04.
Okay.
Okay. So thank you.
Okay.
Yes, sir.
Yes, sir.